Suppose I give you a quadratic polynomial fx equal to x square minus 5x plus 6, and I say you to find the roots of this quadratic polynomial. How you will solve it? Well, you will set it equal to 0 and you will get two roots from here, alpha and beta, right? So how you will solve this? Either you will apply quadratic formula or you will just complete the square to get to the result, that is the solutions or roots. But in this lecture, I'll teach you all how to solve a quadratic polynomial using Taylor series and calculus. So let's understand what is the procedure to find the roots using Taylor series and calculus, and it will be a really nice and interesting lecture. So please watch till end, and please to like, share, subscribe, and please support this video. So this is the quadratic polynomial. Okay. So let's see how you'll find the root. So fx is x square minus 5x plus 6, right? Okay. So we all know that the graph of a quadratic polynomial looks like this, right? Okay. So there will be a point over here which we call as vertex, right? So let's find its value. So for that we have to differentiate the function to find the critical point, and then we'll check for the maxima or minima, since of course the coefficient of x square is positive, so it will be an upward facing parabola, but still we'll check it. Okay. So f dash x is 2x minus 5. So to find the critical point, we'll set f dash of x as 0, that is at the point where the slope will be 0, right? This is the slope, the tangent at any point, right, where the slope becomes 0. Okay. So 2x minus 5 is equal to 0. So x is equal to 5 by 2. Okay. Now differentiate it second time. F double dash of x is 2, and since it is greater than 0, this implies x is equal to 5 by 2 is the minima. Okay. So this will be 5 by 2 comma, let's solve for the ordinate value. It will be equal to 5 by 2 square is 25 by 4 minus 25 by 2 plus 6, right? So you will get negative 25 by 4 plus 6, and you will get from here negative 1 by 4. Okay. So this is the point, the minima. Okay. So now how you will apply Taylor series to get to this result? Well, just a minute, let me erase this and then I will tell you. We all know that Taylor series about a point, suppose x naught is given as function at x naught plus f dash at x naught divided by 1 factorial times x minus x naught raised to power 1 plus f double dash at x naught divided by 2 factorial x minus x naught raised to the power 2, and so on and so forth to infinity, right? Now notice one thing, we had got fx, we were given in the question itself, x square minus 5x plus 6, right? And f dash x was 2x minus 5, correct? And f double dash of x was 2. So any derivative with respect to x will be equal to 0 if n is greater than 2. F double derivative is a constant, so any derivative after that will be 0. It's obvious. So let's find fx. So for x naught, let's assume it as 5 by 2, because in that case f dash of 5 by 2 will be equal to 0. So it will make calculation a bit easier, right? Okay. So fx is function at 5 by 2 plus f dash at 5 by 2 by 1 times x minus 5 by 2 plus f double dash x naught 5 by 2 actually divided 2 times x minus 5 by 2 whole square, and rest all the terms will be 0. So we don't need to worry about that. Now f dash at 5 by 2 is equal to 0. We had proved, because it is a critical point. When you set it equal to 0, that x is equal to 5 by 2. So when you substitute it back, you will get 0, right? So this will be 0. So we have fx is equal to negative 1 by 4. So this function at 5 by 2 was equal to negative 1 by 4. That is why I calculate the ordinate value over here. Okay. So negative 1 by 4 plus f double dash of x is equal to, so 2 by 2 x minus 5 by 2 whole square. Correct? Okay. So you get fx is x minus 5 by 2 whole square minus 1 by 4. Correct? Okay. And now we want it equal to 0. We want to find the root, so we have to set it equal to 0, right? Okay. So set it equal to 0, you will get x minus 5 by 2 whole square is equal to 1 by 4. Now let's take a square root both sides. You will get x minus 5 by 2 is plus minus 1 by 2. So from here you will get x is 5 by 2 plus 1 by 2, or x is equal to 5 by 2 minus 1 by 2, which is equal to 3, which is equal to 2. So alpha is equal to 3 and beta is equal to, or alpha is equal to and beta is equal to 3. So basically the roots are 2 and 3. So that is how you apply Taylor series to find the roots of a quadratic polynomial. So let's take another example and then we'll move to the proof of quadratic formula using Taylor series, right? Okay. So suppose let's take a random example. Fx is equal to x square plus, suppose let's take the example as 3x plus 4, right? So let's find its root. Okay, so it will have the roots alpha and beta, let's assume that. Okay, so it will look like this, the graph, and this will be some point. Okay, so solution. So we are given that fx is equal to this polynomial, this quadratic polynomial. So fx is x square plus 3x plus 4. So f dash of x is 2x plus 3 is equal to 0. So you'll get x is equal to negative 3 by 2. Okay. So this is negative 3 by 2, and when you substitute it back to get the ordinate value, what you will get? F at negative 3 by 2 is equal to 9 by 4 minus 9 by 2 plus 4. So you get negative 9 by 2 plus 4, which is equal to negative 1 by 2. Correct? So you'll get this value over here. Correct? Okay. So now what's next? Well, let's check it over here. So we have what over here? Negative 1 by 2. Okay. So sorry, this will be 1 by 4. Sorry. So it will be equal to 16 minus 9, that is 7 by 4. Okay, sorry, 7 by 4. So please check the calculation once more. 4 into 4 is 16. 16 minus 9 is equal to 7. 7 by 4. Okay, correct. So what's next? Okay. So we have what x equal to negative is negative 3 by 2, and f double dash of x is 2. That is again greater than 0, which means that this point is minima. Okay. So what's next? Well, we have to find the Taylor form of this quadratic equation. So let's see what we get. Okay, let me erase this. So we have this quadratic polynomial fx, x square plus 3x plus 4. We have fx is x square plus 3x plus 4. F dash of x is 2x plus 3. F double dash of x is equal to, and f n derivative with respect to x is 0 if n is greater than 2. Okay, this is n if n is greater than 2. Okay, so we have this quadratic polynomial. So let's find the Taylor series about negative 3 by 2, because again the derivative with respect to x will become 0 in this case. So this will be equal to f at x naught plus f dash at x naught by 2, sorry, by 1, x minus x naught plus f double derivative of at x naught divided 2 factorial x minus x naught whole square, right? And all other terms will become 0. Correct? So fx is equal to, what is, let me write it over, negative 3 by 2 f dash at 3 by 2 negative 3 by 2 1 factorial x plus 3 by 2 plus the quantity f double derivative at negative 3 by 2 divided by 2 times x plus 3 by 2. So that there is no confusion why I have written plus 3 by 2, because x minus 3 by 2 is equal to x plus 3 by 2. Okay, for if you have any confusion you can understand it. Okay, so fx, what is function negative 3 by 2? It is equal to 7 by 4. Okay, 7 by 4, and this will become 0. Okay, plus 2 by 2 times x plus 3 by 2 whole square. Correct? Okay, so you get x plus 3 by 2 whole square plus 7 by 4, and since we want the root, so we'll set fx as 0, so we'll set it equal to 0. So you'll get x plus 3 by 2 is negative 7 by 4, so you get x is negative 3 by 2. Well, let me solve it only. X plus 3 by 2 whole square, when you take both the square root, it will become root 7 by 2 iota plus minus. The square root of negative 1 is equal to iota. Correct? So from here you will get x is equal to negative 3 plus root 7 or I root 7 by 2 by 2. Correct? And x1 and x2 is negative 3 by 2 minus I root 7 by 2. Correct? Okay. So this is x1 and this is x2. Okay. So this is 3 by 2 and this is plus minus root 7 by 2. Okay. So these are the roots of this quadratic polynomial. And now let's take a general quadratic polynomial, and then solve for its roots. Okay. So suppose fx is ax square plus bx plus c. Correct? Okay. So its graph will be like this or will be like this. Okay. Though it doesn't matter for now. So let's assume it as an upward facing parabola. Okay. So fx is ax square plus bx plus c. Correct? So f dash at x will be equal to ax plus b. Correct? Okay. So set it equal to 0. So you will get x equal to negative b by 2a. So it means that the abscissa value of this point will be negative b by 2a. Now we have to find the ordinate value over here. Okay. So function at negative b by 2a will be equal to a times b square by 4a minus b square by 2a plus c. Correct? Okay. A square. So a and this will get cancelled. So you will have b square by 4a minus 2b square by 4a plus c. Right? Okay. So this is equal to c minus b square by 4a, so it will be equal to 4ac minus b square by 4a. Correct? So you get over here either you can c minus b square by 4a, either you can write this or you can write this whole expression 4ac minus b square by 4a. Okay, whatever you want to write you can write. Okay. So now let me erase this and then let's solve further. Okay. And one more thing, f double dash at x will be equal to a, right? So if a is greater than 0, then in that case it will be a upward facing parabola, and if a is negative, then it means that that value, this negative b by 2a is represent the maxima, right? And since it is represent the maxima, it means that the graph will look like this. This is the maxima. Okay. So if it is greater than 0, then minima, and if it is less than 0, then maxima. Okay. So now let me erase this and then let's write the Taylor series of this general quadratic polynomial. Okay. So fx is equal to f at x naught plus f dash at x naught divided by 1 factorial times x minus x naught raised to power 1 plus f double dash at x naught divided by 2 factorial x minus x naught whole square. And if you don't know what is Taylor series, just watch the one shot on Taylor series and Maclaurin series, which I have already made I guess 1 year back. In that I've taught everything regarding Taylor series, how it is derived, and about Maclaurin series. I have derived everything over there, and it is for BTech, so you can check it out if you want. Okay, so it is in function in single variable. Okay, if you want to know the name of that lecture. Okay, and I taught it separately also, Taylor series and Maclaurin series. Okay, so either ways you can check it out. Okay, so fx is equal to this quantity, I mean this expression, right? So we had got so let's find the Taylor series about negative b by 2. Okay, so fx is equal to this quantity, so fx negative b by 2a plus f dash at negative b by 2a 1 times x plus b by 2a plus f double dash at x naught, that is negative b by 2a 2 times x plus b by 2a whole square. Now clearly this negative b by 2a, so x minus b by 2a is x plus b by 2a, to avoid any confusion over here. Okay, so what is function in negative b by 2a? It is equal to this quantity. So I can write it like this also, or like this, so whatever, wait, I can write it. So 4ac minus b square by 4a, correct? Okay, and what's the value at f dash? It will be equal to 0, right? Plus 2a, we had proved that it is equal to 2a, so 2a f double dash at x was 2a. 2a is a constant, so it doesn't matter whatever you plug in there, you'll get 2a only, times x plus b by 2a whole square, correct? Okay, so what's next? Well, let me tell you. Okay, so we have got this expression, right? So 4ac, let's simplify it a bit, minus b square by 4a plus a times x plus b by 2a whole square. Let me write it properly. So you'll have a times x plus b by 2a whole square plus 4ac minus b square by 4a is fx. And what is fx? Fx is equal to this expression. So you can write this as a times b by 2a plus 4ac minus b square by 4a, and it is actually the vertex form of quadratic polynomial. Okay, correct, this is the vertex form. So let's solve it. So you want fx to be equal to 0. So from here you get a times x plus b by 2a whole square is equal to this is equal to 0, so you bring it over there, so you will get b square minus 4ac by 4a. Okay, get this? Okay, so x plus b by 2a whole square is equal to b square minus 4ac by 4a square. So when you take a square with both sides, you get a plus minus over here, so you will have x plus b by 2a is root b square minus 4ac divided by the quantity 2a, correct? You get this expression over here, right? So from here what you will get? You will get x plus b, so x is equal to negative b plus minus root b square minus 4ac by 2a, and this is the quadratic formula, right? So you started with the quadratic polynomial and you found its vertex form using a Taylor series, and then you solve this expression, and then you ended up at the quadratic polynomial, the quadratic formula which you use every day, right? Okay, so this is how you derive everything using calculus and Taylor series. And I hope that you must have seen for the first time that we can solve quadratic equation using Taylor series and calculus. And I hope so that you must have enjoyed this video, because there's something very new you must have learned today, because you every day use this formula and you derive it also using square completion method, right? But today what we learned is that the application of Taylor series in deriving the quadratic formula, right? I know it made the things a bit more complex, but it doesn't mean that it is worthless. It is really good practice, right? So I hope that you enjoyed this video, and if you did, then please do like, subscribe, and please support this video. Bye bye, take care.